Hi guys, in this video we will see importance of stress strain curve, including how stress and strain changes as the load increases for ductile and brittle materials. Before we run through the concepts, another important action for you is please subscribe to my channel Learning Directory to get further updates on my channel. Let's run through the concepts. First we will understand the importance of stress strain curve. Before that, we will see how do we plot or draw a stress strain curve. To get the stress strain curve for a specific material, there is something called as specimen tension test, for which a specimen meeting the ISO standard is required. Along with that, specimen tension test equipment is also required. With specimen and test setup, a tensile test will be carried out, and with the test readings, stress strain plot will be drawn, and this is called stress strain curve. A sample stress strain curve is shown here. By using the stress strain curve, the behavior of the material and its usefulness in engineering applications can be obtained. Mechanical properties of material that can be determined from stress strain diagram are proportional limit, modulus of elasticity, elastic limit, yield strength, ultimate tensile strength, modulus of resilience, modulus of toughness, percentage elongation, and percentage reduction in area. Now let us go into details of stress strain diagram for a ductile material. Figure shows the typical stress strain diagram of a ductile material such as cast iron. When we say ductile, it will have a significant plastic deformation before failure. Coming back to stress strain diagram, when a component is loaded gradually, stress is induced and we see change in length of the specimen from which strain is calculated. Initially, this stress and strain changes linearly till the point called proportional limit, mentioned as P in stress strain diagram. On further loading, there will be deviation from linearity in stress strain curve, and after a certain point, we will see that the material is not able to regain its original shape, that is, atoms displaced from its original position are not regaining its original position. So the point where the material is not able to regain its position is called elastic limit, represented as E. Beyond a elastic limit, on further increase in load at a point, there will be large deformation even though there is no increase in load. That point is called yield point. In case of mild steel, it is observed that there is a small reduction in load. The curve drops down to point Y2 shown in image immediately after the yielding starts. In this case, Y1 is called upper yield point and Y2 is called lower yield point. In many cases, Y1 and Y2 cannot be differentiated. It will be very close to each other. On further increase in load beyond the yield point, the plastic deformation will increase and specimen become hard due to strain hardening, and higher load is required to see the deformation. As the load increased on the specimen, the stress reaches to its peak value called as ultimate strength or ultimate tensile strength, represented as U. Beyond ultimate strength, specimen will undergo a localized reduction in area which is called as necking, and then fracture takes place. The stress at which failure happens is called breaking point, and the stress at this location is called breaking strength. So this is how the stress and strain changes for a ductile material. Now let us see how stress and strain changes in case of brittle material. It is very much different from ductile material as shown in image. Example of brittle material is cast iron. As we see from image, brittle material stress strain curve is non-linear at very early stages of loading the component, and it will not have any defined yield point. Also, brittle metals will not have any considerable plastic deformation or necking like in ductile materials. Fracture happens all of a sudden when stress reaches to tensile yield strength represented as U. Now let us see how do we determine the properties of material from stress strain curve. The first property is proportional limit. It is defined as the stress at which the stress strain curve start deviation from straight line. As discussed earlier, stress and strain will be linear till point P, which is proportionality limit, and then it will deviate. The stress at a point P is called proportional limit. Next one is modulus of elasticity, also called as Young's modulus. It is a ratio of stress to strain up to the proportional limit. We discussed this proportional limit just before we discussing this modulus of elasticity. This modulus of elasticity is given by slope of stress strain curve till the proportional limit, that is between point O and P as shown in image. Beyond point P, even though the stress strain curve is deviating from straight line, still material will return to its original shape, that is still it will be in elastic region. Hence the point E beyond which the material cannot regain its original position or shape is called elastic limit. Next property is yield strength. Yield strength is defined as the maximum stress at which there will be marked increase in elongation without any load increase. That is, even at constant loading, there will be considerable elongation. The point is called yield point. As discussed earlier, few materials will have upper and lower yield points, but for many of the materials, there will not be any upper and lower yield points that we can differentiate. This property is ultimate tensile strength. Beyond the yield point, when load is increased, elongation will be small because the material will become hard due to strain hardening, and as the loading increased further, stress will reach the maximum point, which is called ultimate stress. Beyond ultimate stress, necking starts as told earlier, and fracture takes place. Stress at fracture is called breaking strength. Next property is resilience or modulus of resilience. It is defined as ability of the material to absorb energy when material is deformed elastically and to release the energy when it is unloaded. Resilient material absorbs energy within elastic limit without permanent deformation. Resilience is measured by parameter modulus of resilience. From stress strain curve, it is calculated as area under stress strain curve from origin to elastic limit as shown in image. Similarly, next property is modulus of toughness. Toughness is defined as the ability of the material to absorb energy before fracture takes place. It is measured by a quantity called modulus of toughness. From stress strain curve, it is calculated as area under stress strain curve from origin to breaking point shown in image. Now let us see another important parameter, that is percentage elongation. It is the ratio of increased length of a gauge section of specimen to the original gauge length, which is expressed as percentage. After fracture, two half of the specimens are fitted together as shown in image and gauge length is measured. Here observe the old gauge. Length is not measured along the complete length of the specimen, it is measured within the specimen gauge as shown in image. Ductility is measured by percentage elongation. As ductility increases, percentage elongation also will increase. Similarly, percentage reduction in area. Percentage reduction in area is determined as the ratio of decrease in cross section of area represented as A of the specimen after fracture to the original cross section A naught, which is expressed in percentage. Formula for calculating percentage reduction in area is shown here. Ductility is also measured by percentage reduction in area. If the specimen has defects such as porosity, inclusions, or any damage due to overheating during the heat treatment process, then the percentage elongation or percentage reduction in area will decrease drastically. Hence, these two parameters, such as percentage elongation or percentage reduction in area, is considered as an index of quality of the material. That is all, guys, on stress strain curve and its importance. Please subscribe to my channel Learning Directory for more updates. Thank you.